I'm Nick Simons. I'm a program manager on the Fluid Framework team, and I'm excited to show you how easy it is to create collaborative experiences using the Fluid Framework. I have a few slides I want to share just to set some context. Then I'm going to demo a component that I wrote specifically for this session. We'll walk through the code. And then there should leave plenty of time at the end for questions. If you have any questions at all as they come to you, please just ask them as I'm talking, and that way we'll have them all queued up when we get to the questions at the end of the demo. Before I joined the Fluid Framework team, I spent about a decade working on the browser-based versions of the Microsoft Office applications. And a big part of my responsibility on that team was helping to stand up and maintain the thousands of servers in dozens of data centers around the world required to deliver that service. So when I joined the Fluid team, I was amazed to find that the rich, collaborative client experiences that we were developing required no servers whatsoever. They were all delivered directly from CDNs and all ran locally in the browser. We believe that the ability to create collaborative experiences without having to write a single line of server code is the innovation that's going to power the next wave of modern productivity. You may have already heard, but we are open sourcing the Fluid Framework. And what that means is we are making available in open source and GitHub the same libraries that we use inside of Microsoft to create these new collaborative experiences. And you will have an opportunity to use those libraries to build your own experiences and, of course, also contribute. When we get to version 1 of the Fluid Framework, the experiences you create can be deeply integrated into Office, Teams, Outlook, and ultimately the rest of the Microsoft 365 ecosystem. And of course, because it's an open source project, you can take those experiences and you can also deliver them in whatever way you see fit. But we're not at version 1 yet. So when we open source shortly, what we're really inviting you to do is come and explore and prototype and really figure out what you can do with the Fluid Framework. And of course, we are really excited to get your feedback and your contributions. We're looking forward to working with you to make the Fluid Framework great. Before I get into my demo, I just want to go over a few of the sort of high-level concepts involved in thinking about the Fluid Framework. When you develop for the Fluid Framework, the majority of all development is happening in the client building Fluid components. And Fluid components are just built using standard tools like HTML, JavaScript, and CSS. What makes those components collaborative is the use of distributed data structures. We call them DDSs. And these distributed data structures can be operated on like local data structures, but the Fluid runtime knows how to keep them in sync across all of the clients. The role of the server in this story is simply to make sure that every client has all the operations that are being performed on these distributed data structures. And what it does is it sequences those operations so that each client is able to reproduce the distributed data structures identically in every client. All right, so let's look at the demo component. So my component is a simulation of a brainstorming session, like you might expect, where a group of people get into a room and everybody gets a pad of sticky notes and a pen, and they write down ideas and they put them up on a whiteboard to share. Now, we're not getting into a room. We're all working from home right now. And so what I want to do is I want to show you we've got a virtual pad of sticky notes here, and you can write on the sticky note. And in this case, I'm just putting the text in automatically. I don't want to spend time typing. And so I can share my idea and put it on the whiteboard. And let's have another idea. And as you can see, now they're on the whiteboard, but there's nobody else here. I'm alone. So in order to make this collaborative, we're going to need to add some more people to the session. So what I'm going to do is I'm just going to grab this URL and I'm going to add some more clients to the session. And as I do that, now we're running a local version of the server, so it is very lightweight and sometimes doesn't connect the first time. But once it's connected, it's extremely reliable. So as you can see, all of the clients now can see the 2 sticky notes that we put up on the whiteboard when we first loaded the component. And now we can just go around and everybody can add their ideas. And as they add their ideas, they immediately show up in all of the clients. So I'll just go around and add some more ideas. And then once we have enough ideas, we will go through the process of picking which ideas are most popular, and we'll do that by voting. And so you can see these are my votes, and I can see other people can see that I voted, and they can also vote. And we just go through that process and it increments. Everybody here has a slightly different view of the whiteboard, but it's clearly a shared collaborative experience. And if I want to know if my ideas are most popular, I can simply highlight those and I can see that one of them is and the other ones didn't get any votes at all. When I'm all done, you could imagine being able to organize these notes and generate a report, and you could, continue to build on this using the tools that you would use to build any other client-side experience. One thing I have done is I've included this tidy up button so we can tidy up and have another session, but it isn't hooked up yet. I'm gonna hook that up when we do the coding, just so I can show you how easy it is to add a new feature. So let's take a look at the code. So what we start with here is I started this project using a Yo fluid generator, and it scaffolded the project for me, and it gave me a primed component, or I'm extending the primed component. And what the primed component does for me is the primed component does some of the initial plumbing to get me connected to the fluid runtime. And most importantly, what it gives me is a root distributed data structure. And this root distributed data structure is a shared directory. I can put a lot of different data in there. It's just key value pairs with some hierarchy. But for this demo, and maybe most usefully, I can put other distributed data structures into that root distributed data structure. The next function I want to draw your attention to is the component initializing first time function. In this function, what I'm doing is I'm creating the distributed data structures that I'm going to use in my component. I'm using shared maps. Shared maps are very similar to normal JavaScript maps like you would be used to working with if you use JavaScript. The only difference between, or the only significant difference between a shared map and a normal map is shared maps are kept in sync by the Fluid runtime across all of the clients. And so I'm creating one for notes, one for votes, and I'm creating one to keep track of some custom user data. The actual code to create these shared maps looks like this. And all we're doing is we're creating the map, and then we're setting it on that root DDS that I talked about just a few moments ago. The pattern is a little bit different than you'd expect because we're using a handle, but ultimately it amounts to the same thing where you're setting the map as an item in the root distributed data structure. The next function that I want to talk about is this function that runs every single time a user joins the session. So essentially, this runs for every browser session, whereas the first one only ran for the first one. And what I want to point to here is, one, we're creating local references to these shared maps. And we're doing that really just to make the calling pattern simpler. As you can see, the calling pattern for a DDS on the root is an async call. That makes things just a little bit more complex, but we can create a local reference and then we can make all of our calls synchronously. More importantly, though, we're also setting up event listeners for our DDSs. And we need to do that because these shared maps, unlike normal maps, can change even when I don't make a change to them in this code, because every client can potentially change those maps. And so here in the create event listeners function that I've created as a helper, you can see we're hooking the value changed event. And then all we do when it fires is we just call this dot render. Let's take a look at that render function now. The primed component, if it actually has a view, also includes a render function. And what we're doing in this render function is we're calling react.render and we're passing it some props. I used React to create the UI for my demo component. I used React because it's something I'm familiar with, but you can use other UI frameworks as well. And ultimately, my React code doesn't know anything about Fluid. I'm not importing any of the Fluid libraries into my React code. All I'm doing is some very, very simple React components, and then I'm passing React the state of the DDSs so that they can be rendered, and I'm passing a couple of functions so that the UI is interactive. Let's talk about one of those functions right now. So here we have the create gnome function. That's the function that allows you to create a new sticky note and put it on the whiteboard. And if we scroll down, we can see that what we're doing in that function is we're taking the text from the React UI and we're creating a simple data structure. And then we're setting it on the notes map, just like we would on a local map. The only real difference here between this set and just setting on a normal map is when we do this, it triggers that event that we are listening to early on, and every single client is now going to call the render function. And what's going to happen is they're going to run this function get notes from board, and that actually goes and fetches all of the data from the distributed data structure. So if we take a look at that function here we have get notes from board. And the line of code I want to draw your attention to here is here we have the same notes map, the same shared map, and now we're iterating through it with a for each. Again, it's a pattern that you're probably quite familiar with. And there's a little bit of complexity because we're combining the data from the votes map and the notes map into a local object, and then we're passing an array of those local objects to the React, which makes things a little bit simpler to render. But that's all I wanted to show you. Ultimately, these are the lines of code that make this collaborative. And as you can see, there aren't very many of them. Now, I had said we would implement the tidy up function, so let's go ahead and do that really quickly. And so all I'm going to do to implement that is I'm going to create a function called clear, and I'm just going to call clear on the two relevant shared maps. So that's the notes map and the votes map. And once I've created that function, I've already plumbed it through in my React code, but let's just go ahead and pass it as a prop. And there we go. That's all we have to do. So now we have a way for any one of the users to erase the whiteboard. Let's actually see if that in action. So we just need to refresh this guy. And now you can see everyone's got a view, and any one of these users could click tidy up, and everything is tidy, and we're ready for another brainstorming session. That is the end of the coding demo and the demo of this component, but I'm really excited to hear your questions and to answer them. And so I would like to introduce at this time my colleague, another program manager on the Fluid Framework team, Tamini, who's going to be working with me to get questions and get them answered.
Hello, everyone. I'm Tamini Mokdisi, and I'll be helping moderate the session. So feel free to ask away any questions that you may have. I see we already have a lot on the feed, so we'll get started right away. So the very first question is, can we use Fluid Framework standalone with no dependencies on other services?
The answer is yes, you can. So the Fluid Framework doesn't take any dependencies on other services. There is a server component that is required in order to keep all of the clients in sync. But there is a reference implementation of that server in the open source repo. So you could, in principle, stand that up yourself and make a completely standalone experience.
Great. The next question is, can the Fluid framework be used with C#?
So the Fluid framework is designed to work with JavaScript runtimes. That there are a number of benefits to using JavaScript. However, you can use C# because you can host a JavaScript runtime in a C# project. So if you wanted to say, use C# for most of your business logic and rendering, you could. But in order for you to actually have the Fluid runtime working, you would need to use a JavaScript runtime like Chakra.
Great. The next question's from Dalton. How does Fluid framework deal with conflict resolutions when multiple people edit the same data?
So that's a fairly complicated question, and it will depend somewhat on which distributed data structures that you use. One of the things which I did in my code is I chose to create one shared map for notes and another shared map for votes. And that was specifically to avoid any issues where two people tried to vote on the same note at the same time, where there might actually be a race condition that would not resolve. So there is some amount of work that you need to do to just think about your data so that you're using the distributed data structures in a way that prevents that kind of stomping on data. However, many of the distributed data structures do have a certain amount of conflict resolution built into them so that they can actually handle that. So some of the more complex ones, like the shared string, actually do the work to make sure that you get a rational output when ops come in from multiple clients at the same time operating on the same region of the data. So it's going to depend on the distributed data structure, and it does require some thought up front to make sure you choose the right structure for your code. But there's an awful lot of work that's gone into the design of the framework and the design of the distributed data structures to make conflict management really easy to handle.
The next question's from Nigel. Is Fluid framework only applicable to the big four? And then in parentheses is Word, Excel, PowerPoint, Outlook. Close parentheses. Or does it support apps like OneNote and Visio?
So the Fluid framework is not attached to any specific application. Internally at Microsoft, we are looking for ways to employ the power of the Fluid framework across our portfolio of products. And in fact, our initial offerings are targeted mostly at our communication platforms like Teams and Outlook, but we're also looking at improvements in a lot of other places. And so certainly there's no tying to the big four, and the opportunities to bring Fluid experiences to Microsoft customers is going to be extremely flexible.
So the next question is, how is authentication and DLP handled?
So authentication is handled any way you want it to be, because there is no authentication built into the Fluid framework. So for example, in this application, I'm sort of faking authentication by just generating a GUID for each user and using that to keep each user in sync when I hit refresh. But you could use any authentication sort of framework that you want. And I feel like I want to know what you mean by DLP, because I'm not 100% sure of my 3-letter acronyms. Maybe we can get a clarification on that so I don't just sort of dive into an explanation of the wrong thing.
Sounds good. While we wait for that one, Nicholas has asked, how do you decide between multiple structures inside the DDS versus multiple simpler DDSs?
So essentially, when you're thinking about your distributed data structures, you want to think about how people are going to interact with that data, so that you can ensure that it doesn't get stomped on, like I talked about earlier. So for example, you could imagine in this example, I would have votes could have been just a property on a note where you increment that property as people vote. But I wanted to make sure that multiple people could vote at the same time without losing data. So that's why I broke it out. When I was designing this, there was some, we had some discussion about slightly more complex structures where you would actually have the objects for the notes and votes sharded out into even more parts of data inside of distributed data structures, which is in some ways more flexible, but also ends up making the demo more complex. You have an enormous amount of flexibility in what you choose, and ultimately it's going to be your judgment as to what's going to work best for your application.
That's true. It is very fluid. So we did get a clarification about DLP. They meant data loss prevention. How it will be handled in Fluid.
So that comes back to all operations are essentially, there's an opportunity to persist those operations, and so consequently you're in a position where even if different users are behaving in ways that maybe appear that there's data loss, where there's a lot of great ways you can build to retrieve information that appears to be gone. So as long as you've designed your application in the right way, there's actually there's essentially a record of every single operation that's taken place in a DDS, and so you can always rewind and get back to a different part of the ops stream to figure out what's happened and to rehydrate data if you feel that it's been lost.
Great. So the next question is, where's the data stored and how's it synced?
So the data is stored, in some ways that's up to the implementer of the server. So for a lot of the solutions that we're building internally at Microsoft, we're using SharePoint to store the actual persisted data, and we're using a .fluid file. But there's nothing preventing folks from storing data in a database or in just blob storage. It's largely up to the implementer, and there will probably be other services that are available that will give developers more options. And that's sort of persistent storage. There's also a certain amount of storage on the server where snapshots of the ops stream are kept so that as new clients join, they don't have to replay all of the ops. They only have to start from a snapshot. And the second question was how we keep all the clients in sync. And the way we keep clients in sync is the server broadcasts all the ops in sequence, with it's stamped with essentially a number, and all the clients then can use those operations to create the DDSs locally. So we're not broadcasting DDSs. There are no DDSs actually stored in the file or being kept on the server. The server is simply responsible for managing ops and broadcasting ops. The clients are responsible for actually building up the data structures from those operations. And because of the sequencing and because they're all running the same JavaScript code, they're able to get to an identical state.
Great. So this next question we actually get very frequently because of the similarity of the names. So the next question is by Nick. Can you speak to the relationship between Fluid Components and Fluent UI?
The names are really similar.
Yeah.
And we actually do work right alongside the team that is building the Fluent UI framework. But the relationship is they're really great together, but there's no dependency between one and the other. Fluent UI is a great UX framework that is based on React, and so I didn't use Fluent UI in this demo because I wanted to keep things very simple, but I very easily could have. And Fluid is what I've been showing, and Fluid is really all about keeping clients in sync and building these components, and less about UI.
So the next question's from Philip. Can this work in a way that allows data to be passed to different applications, or does it require the same application? And then in parentheses, Can I use it to pass a sticky note from your React application to Microsoft Teams?
So absolutely you can. In fact, we've been talking a lot about collaboration in this talk, but one of the real powers of the Fluid Framework is the component model. And what the component model effectively allows is for any application that has sort of a core understanding of how to load a Fluid component. And so right now we've already taught Teams and Outlook how to load Fluid components. And of course, there are many, many other applications that are also going to be learning this trick, and it's not a hard trick to learn. You could imagine I could have written this so that each of those sticky notes was actually its own component, because components are composable and can all be combined. And then it would have been very simple for someone to simply pull a component out like a sticky note and drop it into some other canvas and have it be fully rendered. And because those are still connected to the same data source, if something were to change, say in that sticky note, it was edited or somebody voted on it, you'd be able to see it in the other application as well as in the original location of the sticky note.
So we're down to our last 5 minutes, so we'll be answering the last few questions. Please make sure you get your questions in. So the next question is by Andre. How can a solution based on Fluid Framework be scalable?
So Fluid is by its very nature extremely scalable. I don't know if you saw the MetaPuzzle demo that we did yesterday, where literally thousands of people were participating in building up a puzzle essentially by doing little mini puzzles, and that was all using the Fluid Framework. So one of the things that makes the Fluid Framework extremely scalable is the amount of work that the server has to do is extremely lightweight. It's really just bringing in ops, stamping them, and broadcasting them. So you could have a server doing and handling thousands and thousands and thousands of requests a second, and it wouldn't really be struggling at all. We actually find that network is probably the sort of the biggest gating factor there, and that's what needs to be managed. And of course, any solution, so that's for a single session, and of course you would use the normal strategies for making sure that load is distributed among a set of servers when you had multiple sessions, so you wouldn't have one server that had to serve all the traffic for an application.
So a similar question, how many concurrent user/clients can be supported simultaneously before it all breaks down?
So I don't know a precise number. I know it is a very, very large number.
Yeah, as we saw with the MetaPuzzle yesterday.
Yes, but I don't have a precise number, I'm afraid. But it's far more than traditional collaboration apps are known to be able to handle.
Great. Let's see here. Can it be used with Blazor or other framework?
So essentially, yes, it can, because in theory, you can use those frameworks to build up your application, and then ultimately it all gets rendered in the browser. But one of the things to note is, because this technology is designed to run in the browser, not on the server, any Blazor application would still be relying on the JavaScript runtime running in the client, not on the server. So you could certainly do that, but it would be a sort of hybrid solution where there would be stuff happening on the server for where you want to run logic there, and then the actual Fluid stuff would still be running in the browser.
Great. So we're actually out of time now. So we do want to invite you to watch our YouTube talk. We just posted it yesterday. It's another Fluid Framework talk that we made for Build. This one is a pre-recorded session. We'll post the link to it on the chat. So if you want to learn more about Fluid, that would be a great resource. Additionally, if you want to be updated on any developer news related to Fluid Framework about our open sourcing release coming up, then go to fluidframework.com and fill out that sign-up sheet we have so that you can continue to be informed. Thank you.
And thank you for listening. Thank you, Tamini, for doing such a great job moderating. And I look forward to seeing what everyone does with the Fluid Framework.